So, in the exercise today, we want to look for relationships between values of sine theta, where theta is acute, obtuse, reflex. So, let's have a look. I'm going to draw out my sine graph and we'll get an idea of what I mean. I'm then going to split my sine graph into 4 quadrants. So, these 4 quadrants are when theta along my x-axis is less than pi on 2 radians, where theta is between pi on 2 and pi radians, or is an obtuse angle, where theta is between pi and 3 pi on 2 radians, or 180 and 270 degrees, and then for bigger angles between 3 pi on 2 and 2 pi radians. And we're going to see where values of sine theta are the same. So let's look within my first quadrant, Q1, and my second quadrant with those obtuse angles of theta. Now, notice here, I'm just going to choose a theta point along my theta axis or my x-axis. So if I choose this theta 1, I'm going to say that sine of theta 1 is around 0.5. If I look in the obtuse section, quadrant 2, I can also see a point where sine is approximately 0.5. And it looks like these are quite symmetrical. So the point along the theta axis, where sine theta is equal to 0.5, looks to be pi minus this length of theta 1. So these values of sine are the same. So I can say that sine of theta 1 is equal to sine of pi minus theta 1, where theta 1 is some acute angle. All right, beautiful. Let's spot some other symmetrical points. So let's see acute again, quadrant 1, but let's look at quadrant 3, this one in dark green here. Can you see any places along here in which sine of some angle here would be approximately, well, say negative 0.5? So I found the spot where I think it would be about negative 0.5. And this looks like, again, well, the distance along the theta axis looks like it'll be pi plus theta 1. And then I have something cool. I could say that sine of theta 1, again, this acute angle, is equal to the negative value of pi plus theta 1. So I have sine theta 1 equals negative sine of pi plus theta 1. Again, some interesting symmetry happening. Lastly, let's look at my acute angles and then my reflex angles between 3 pi on 2 and 2 pi radians. Can you see anywhere in this fourth quadrant where the value of sine theta is again maybe negative 0.5? It's not going to be positive, but it might be negative. I'm thinking it's going to be here just near the end. Again, the distance along the axis looks like it would be, well, that's 2 pi minus theta 1. So I have another point of reflection and symmetry. So here I can say that sine of theta 1 is equal to, again, the negative of sine 2 pi minus theta 1. What does this mean? This means you can find values of sine that aren't just in right angles, where the angle is bigger than 90 degrees, as long as you know some key values for sine within right angle triangles. So for instance, using our first finding, we could say that sine of 180 minus 30 degrees or sine of 150 degrees, that's equal to sine of 30 degrees. So if I know sine of 30, I know sine of 150. Using the second finding, if we have, or we know sine 30, I can figure out what sine of 180 plus 30 is. 180 plus 30, that's 210. So sine of 210 this time would be negative sine of 30 degrees. And these could be in radians or degrees. I'm just putting them in degrees for simplicity here. Lastly, we could have, again, if we know sine 30, and if we have an angle, say, sine 330, well, that's really 360 minus 30. So I could say that sine 30 is equal to negative sine 330, or that sine 330 is equal to negative sine of 30. To get a better idea, let's look at two examples. Okay, find the value of the following. This time in radians, I have sine 5 pi on 4. Now let's pretend off the top of my head, I don't know what that is. Well, I need sine pi plus something, pi minus something to use my rules. So I have sine 5 pi and 4. That's pretty close to pi plus a little bit extra. So I have sine, this is really 4 pi and 4 plus pi and 4. That is equal to sine pi plus pi and 4. And then I think, okay, well, I know one of my rules kind of looks like that. If I look at my second rule, I have sine pi plus an acute angle is equal to minus sine of that acute angle. So sine pi plus pi on 4 is really equal to negative sine of my angle pi on 4. Now I can use a right angle triangle to figure out what that is. Well, I know sine pi on 4 is 1 over root 2. So negative sine pi on 4 is negative 1 over root 2. That means sine 5 pi on 4 is equal to negative 1 on root 2. Let's try it for sine 11 pi on 6. 11 pi on 6 is pretty close to, not pi, but it's pretty close to 2 pi. I can write 11 pi on 6 as 12 pi on 6 minus pi on 6. 12 pi on 6 is 2 pi minus pi on 6. Okay, I can see I have this last rule, rule 3 here, that sine 2 pi minus theta equals minus sine of that theta. My theta here is pi on 6. So I get that sine 2 pi minus pi on 6 is equal to negative sine pi on 6. I know what sine pi on 6 is using, again, right angle triangles and a little bit of trick. So I get that sine 11 pi on 6 is equal to minus a half. Now the same applies for cos, except the rules are slightly different. So take your time to write out the rules and then do the examples with me. Example 1, we've got to try and find cos 3 pi on 4. So remember, I want to make this equal to cos pi plus a theta, pi minus a theta, or 2 pi minus theta. 3 pi on 4 is close to pi. We just subtract pi on 4. So cos 3 pi on 4, I can really write that as cos 4 pi on 4 minus pi on 4, or cos pi, right, that's 4 pi on 4, minus pi on 4. Sweet. Okay. This, if I look at my rules for cos, kind of looks like, let's see, the first rule here at the top, where I have cos pi minus theta equals minus cos of that theta, where that theta is acute. So if I'm lucky, I know that cos pi on 4 is 1 over root 2, again using triangles, and I just stick a negative sign in front. So cos 3 pi on 4 is really equal to minus 1 over root 2. Lucky last example. Cos 25 pi on 4. Okay, now we have a big number. Again, Doesn't look like I'm going to have pi plus or pi minus. But let's see. I know 25 pi on 4. Well, that's pretty close to 24 pi on 4. And I do that because I can simplify that to 6 pi plus pi on 4. So let's look. If we simplify it and break it up like this, we will get 6 pi plus pi on 4. Notice that 2 pi is once around my unit circle, 4 pi is twice, 6 pi is 3 times around, so I'm really back to 0 on my x-axis, and I'm adding on just pi and 4. So cos 6 pi plus pi and 4 is really the same as cos pi and 4, hey? And I don't need to use a rule because I know this is 1 on root 2. So trig can be a little bit tricky, but have a go at these questions. There are different ways to do this. Some people like using the unit circle, some people like using the graph. See how you go. Let me know how you eventuate with 14a. There is a little bit more on the relationship between sine and cosine, and that's in the textbook for this section.